Okay, now we are going to do the example 10.20. So the question asks us to approximate an answer depend on this differential equation and a boundary condition. Okay. The differential equation is the gradient of, or we can call it a rate. Instead of gradient, we can call it rate of x equation, xt. So this we can from this gradient we can approximate the value of, or the location of point in curve xt. Okay, and the given initial condition or boundary condition is when x is equal to 1, when t is equal to 1, x will be equal to 2. So that is the initial condition. So that is our first point. So the coordinate is 1, 2. So actually we can make a curve, x versus t. So the first point should be 2, 1, 2. So it's somewhere around there. 1, this 2. Okay. And okay, what the question this question asks us is this to find the value of t. To find the value of x at t is equal to 2. So when t is equal to 2 right here, we want to know what is the value of x. So what is the value of x? Okay. So how to do this? Again, we can use the iteration process. So instead of drawing the curve, we can draw the curve if you want, but we can just do some calculation, and based on the Euler's method, Euler's equation. So what we can do is we can use this equation, this Euler's method equation. So the given right here is the time step is 0.1 right here, and the whole process will be between 1 and 2. So 1 and 2, when we minus it, 2 minus 1 is equal to 1. So how many time step we will be in this numerical solution is depend on the time step. So 1 divided by 0.1, it will be 10. So there will be 10 calculation process that we need to do to get the final answer, or which is this one. Okay, so I will show you how to do that. So actually we can make a table like given in the answer in the book. So we can make a column. So we will have t column, x plus t, x t h, x plus t over xt. So I will tell you why we need to calculate this. So actually it depends on the equation right here. So this column depend on the equation, so don't get confused. This will not be in all different question, so it depend on this question only. So what we are going to do is actually this function is is the f function. Okay, the f function which is similar with this one, and we will use the same formula actually. We will use this formula in this case as well. So this is just to simplify our calculation. Actually, we don't have to do this. We don't have to do this. We just need to find this only. Okay. So for the first step is we know that the boundary condition, this one. So we put the first value of t, which is 1. And we know that the value of x is 2. So actually we don't have to do this. It's up to you. You can do that also to simplify your process. Or you can just put these two values inside this function. Right. So when we put these two values inside this function, we can get the value that we want. So we know h, we know the value of h. So let's say in this case, I don't want to follow the book, so I just erase this column. So I'll just find this term. I will just find this term. Okay. So when I put 1 inside here, inside this equation, and x inside the equation, I will get same value as in the book. So I will get 0.15. Okay, so this is value of h time the function. Okay, what this value means is same like this. So this one. So that is the increment of x. So next is after I get this value, is it finished already? Not yet, because I want to find the value of x at t is equal to 2. So and the increment of t is 0.1. So the next point will be 1.1, right? Because so let's say this t0, t1, again when I look at this equation right here, or this one, t1 is actually equal to t0 plus h. So t0 plus h is this one, right? Okay. So what is the value of x? x2. So this is x0, this is x1. Actually x1. So what is the value of x1 is this value plus this value. So 2.15. If you look at the table, I get the correct answer, right? So we continue the process. We put these two values inside this equation again, and then I will get the answer 0.1374. Okay, so so I just write it so it will be clear. So t2 is equal to 1.2 because 1.1 plus 0.1 right here is equal to 1.2. So when I put this value, so for x2, for this value is this value plus this value. So if I look closely, I will try to add it. So it will be 2.4782. Okay, 2.2874. Right. So it is similar with the one in the book. So when we put this value again in this equation again, we will get, you can try this by yourself, 1271. So we can continue this process until we get the perhaps T9 or T10, where the T value is 2. Okay, and when you do this iteration process, we call it iteration process, you will finally get the final answer, which is 3.1162. Okay, you can try this by yourself. So that's it. That's the solution. That's the method, the numerical solution, Euler's numerical solution in solving this problem. Okay, thank you.